Hi students, we will continue our lesson with Born-Haber cycle part 1. At the end of this video, you should be able to define lattice energy, electron affinity, and ionization energy. As you have learned, ions are particles bearing an electrical charge. A cation forms when a neutral metal atom loses one or more electrons from its valence shell, and an ion forms when a neutral non-metal atom gains one or more electrons in its valence shell. Compounds composed of ions are called ionic compounds, and their constituent ions are held together by strong ionic bond which is formed from the electrostatic forces of attraction between oppositely charged cations and anions. The attraction draws the ions together, releasing energy and causing the ions to form lattice. The principal reason that ionic compounds are stable is the attraction between ions of different charge. A measure how much stabilization results from the arranging of oppositely charged ions in an ionic solid is given by the lattice energy. So let's learn the definition of lattice energy. Lattice energy could be described in either of two ways. Let's look at the first one. Lattice energy is defined as energy released when 1 mole of solid ionic compound formed from its gaseous ions. For example, sodium chloride has lattice energy negative 771 kJ per mole. It means that when 1 mole of sodium chloride solid is formed from 1 mole of sodium gaseous ions and 1 mole of chloride gaseous ions, 771 kJ energy is given out. The second definition of lattice energy is energy required to completely separate 1 mole of a solid ionic compound into gaseous ions. The same amount of energy is required to completely separate 1 mole of solid sodium chloride into its gaseous ions. This is called lattice dissociation enthalpy. Magnitude of lattice energy. The magnitude of lattice energy of an ionic compound depends on ionic charges and ionic size. Lattice energy is proportional to the ionic charges and inversely proportional to ionic size. The larger the lattice energy, or more exothermic the lattice energy, the more stable the ionic solid. Its value is an indicator of the strength of ionic bonds in the ionic crystal. The larger the lattice energy, the stronger the ionic bond. Ionic crystal with highly negative lattice energy have strong ionic bond. Let's look at this example. If you can see, the lattice energy of magnesium oxide is more negative than the lattice energy of magnesium chloride. Magnesium oxide is composed of magnesium ion and oxide ion, whereas magnesium fluoride is composed of magnesium ion and fluoride ions. The charge of oxide ion is higher compared to fluoride ion. The electrostatic force of attraction between magnesium ion and oxide ion is stronger than between magnesium ion and fluoride ion. In other words, magnesium oxide has stronger ionic bond than magnesium fluoride. Thus, the lattice energy of magnesium oxide is higher or more exothermic than magnesium fluoride. The following example explains how size of ions affect the value of lattice energy. When 1 mole of solid lithium fluoride is formed from 1 mole of lithium gaseous ion and 1 mole of fluoride gaseous ion, 1036 kilojoule energy is released. When 1 mole of solid sodium fluoride is formed from 1 mole of sodium gaseous ions and 1 mole of fluoride gaseous ions, 923 kilojoule energy is released. If we compare the value of lattice energy of lithium fluoride is more exothermic than sodium fluoride. You can see the size of lithium ion is smaller than the size of sodium ion. What is the relationship between the size of ions and lattice energy? The distance between lithium ion and fluoride ion in lithium fluoride is smaller than the distance between sodium ion and fluoride ion in sodium fluoride. When these ions form ionic bond with fluoride ion, the electrostatic force of attraction between lithium ion and fluoride ion is stronger than between sodium ion and fluoride ion. As a result, the lattice energy of lithium fluoride is more exothermic than sodium fluoride. Electron affinity EA. Generally, electron affinity is the energy change when 1 mole of gaseous atoms gain 1 mole of electrons to form an ion. For example, when 1 mole of oxygen gaseous atom gains 1 mole of electron to form O- gaseous ion, 142 kilojoule energy is released. This process is called first electron affinity of oxygen. 844 kilojoule energy is absorbed when 1 mole of O- gaseous ion gains 1 mole of electrons. This process is called the second electron affinity of oxygen. Ionization energy, IE. It is defined as minimum energy required to remove 1 mole of electrons from 1 mole of gaseous atoms or ions. For example, removal of 1 mole of electrons from 1 mole of magnesium gaseous atoms to form magnesium plus gaseous ions, 738 kilojoule energy is required. This is called first ionization energy of magnesium. When 1 mole of electrons is removed from 1 mole of magnesium plus gaseous ions to form magnesium 2 plus gaseous ions, 1451 kilojoule energy is required. This is called the second ionization energy of magnesium. Alright students, we will continue how to construct Born-Haber cycle in the next video. Thank you.